I think the distinction between microservices and monoliths is something that's kind of overblown to a certain respect. Like, you can definitely take a lot of the deployment aspects you're referring to and apply them to microservices. You know, when we do a production deploy of, I don't know, for want of a better term, a macro service, we tend to update all the microservices to the same Git shard. So we know they all work together. But the nice thing about the microservice approach is that in between those big deploys, you know, we maybe do these big deploys once a day or once every few days. In between these big deploys, you can tune individual services. You can maybe deploy a bug fix that only touches one service, you know, in a kind of case-by-case basis, which is flexibility you don't really have with monoliths. But then just to like throw a spanner in the works, like you used to be able to do this with Erlang, right? Erlang arguably was a monolith, you know, a monolithic architecture, but you could easily just hotfix in a single function, right?
Could you? I don't know. Could
you could, yeah. Yeah, this is when languages were powerful and let you do things like that.
Yeah.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean's developer cloud makes it simple to launch in the cloud and scale up as you grow. They have an intuitive control panel, predictable pricing, team accounts, worldwide availability with a 99.99 uptime SLA, and 24/7, 365 world-class support to back that up. DigitalOcean makes it easy to deploy, scale, store, secure, and monitor your cloud environments. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. We have episodes on WebRTC, immediate mode GUIs, and Black Hat Go coming down the pipeline. So be sure to subscribe if you haven't at changelog.com/GoTime, or just search for Go Time in your favorite podcast app. You'll find us. Okay, here we go.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking microservices versus monoliths. My co-host today, it's Jana Bidogan. Welcome back, Jana.
Hey, how are you?
Good. How's it going?
Good. Just self-isolating. What about you?
Same. Just self-isolating and practicing. I've been practicing for a few years now, so I'm really kind of getting good at it. You know, this subject, microservices and monoliths, often generates a lot of heat, but not today, not on this show, because Jana and I have sourced two extremely cordial and polite young men. The first is Matt Heath from Monzo. Matt's a senior staff engineer at Monzo, which is a bank here in the UK, where he works on Monzo's microservices platform. Hello, Matt.
Hello. Thanks for having me.
Well, thanks for coming. I really appreciate it. Don't worry, though, you're not on your own. We're also joined by Tom Wilkie from Grafana Labs. Tom's one of the Prometheus maintainers and author of the Cortex and Loki projects. In his spare time, he brews beer and tinkers with his 3D printer. Hello, Tom.
Hello, Matt. How are you?
Did you like my sort of local radio intro?
It didn't sound scripted at all.
It's not at all, no. What sort of tinkering do you do on your printer, on your 3D printer?
Well, for all your listeners, I can actually switch the camera over and show you right now what's printing.
Great, yeah, the listeners are going to be loving this.
They're going to really enjoy the video of, I'm not quite sure what it is yet.
The video doesn't go out, Tom, so this is just...
Is this just for me, is it?
Yeah.
Oh,
yeah, the video doesn't get broadcast.
Okay, I'll put it back to my face then.
No, don't worry.
Well, I don't know how much you know about 3D printing, but mostly my 3D printer prints more 3D printers.
Oh, really? That's asking for trouble. I'm sure that's how Terminator
sounds
started.
dangerous.
Yeah. I've got a 2D printer, and I was looking at it the other day and thinking, do you know what? There just aren't enough Ds.
Yeah.
So, I mean, I'd love to have a 3D printer, mate.
I could print you one.
I love the idea. You can just print them. So let's, I know you, both of our guests. Jana does too, and some people probably seen you doing the circuits in conferences and on online, on videos, and doing talks and that. But for anyone that hasn't come across you yet, why don't we kick things off, get to know each other? Does anyone have any working from home tips? A lot of us are finding ourselves working at home these days. Has anyone got any tips for it?
I think mine are the kind of fairly simple ones I've heard a few people say recently. Turn Slack notifications off, like strongly off. But I can't describe how much more relaxed I feel now there's not a red bubble on my dock on my Mac. And I can still check in and I can still do all the stuff, but I'm just a lot more relaxed. I was really surprised by how much of a difference that made. That and just having like a nice place to work, get a plant, that kind of thing.
Yeah, that's nice. I actually think you could go a step further. Since we're not going to have any guests for a while, any of us, just do whatever you want with your furniture. Just you don't have to follow any of the simple, normal rules, I think. Just do
What do you
anything.
have in mind?
I mean, literally, like, move the bath into the living room. Because imagine that. Just watch telly while you're having a bath, for example. But, like, where you put your desk, where you work, you could, like, carve out a new little corner. You know, sometimes you have to get creative with the space you've got, especially if you're living in the cities. So I think that, yeah, like, you're not going to have any guests for a while. Turn your sofa round, if that helps. I don't know if that helps. But
Face the wall.
well, yeah, maybe. But you can just do what you want, can't you? Kind of free.
I mean, there's not much happening outside the windows these days, so...
Yeah. Yeah, that's true. So, Tom, do you have a working from home tip?
I do, yeah, but it doesn't work anymore.
Oh, really?
Yeah, so I've been working from home for, I don't know, 3 or 4 years now.
Yeah.
And the trick was making it look like you weren't at home. Otherwise, you took the parcel deliveries for the entire street.
Oh.
But now everyone's at home, it doesn't work.
Well, you don't need also that service anyway, because everyone's in. They can just get their own parcels.
Exactly. That's kind of what I mean. I'm glad you understood that.
Okay, great. So microservices versus monoliths then. Let's get into that. What do you want to say about it? I mean, for anyone that doesn't know what these two things are, does anyone want to give a kind of broad overview and highlight of what we're talking about here?
Yeah, I can, well, give a brief intro. I'm sure you can all correct me. The way I see it is, a long time ago when I started writing software, I'd write fairly straightforward web applications, and I'd have one application, one code base, and I'd deploy it in one go. And that was really quite nice and simple. And you have one component, and that has lots of pros and lots of cons. And I think, as certainly my experience, as the applications have got larger and larger, sometimes you want to break those things into smaller components. And you could do that through classes or various other approaches, depending on the language, modules, obviously, in Go. And then I think the real difference is if you want to deploy them independently. So that's certainly the approach that I've seen quite a lot, where you have a number of applications that are either relatively simple servers, but you can have many of them and they all talk to each other through HTTP or some other mechanism. You might have a small number or you might have a very large number of them. That will depend.
Yeah, I think size is going to be a recurring theme on this show, because I have a similar thing to you, Matt. I started off, I would just build little monoliths, really, and in fact, sometimes that's kind of where I start everything, actually. You know, I start with just keep it really simple, and then at some point you kind of can start to feel some pain, can't you? And you can see now that you can see kind of how microservices came to address that. What sort of pain points does it actually help with?
I think from a microservice perspective, there's really a couple of key things that make it attractive for someone like myself. One is isolation. You know, in the services that we run, it's very useful to kind of isolate, let's say, the read path and the write path. You know, we run like hosted monitoring services, right? So being able to put the write path, which is super predictable, which is very, you know, steady and stable and kind of stateful, so pretty critical. Being able to put that in one set of components, one set of services, for want of a better term, and then put the query path, which can be kind of maybe dynamically scaled, can, you know, be a bit more risky, a bit more stateless. Putting that somewhere else, like, allows you to kind of separate out, you know, the blast radius of bugs, for instance.
Matt, so you mentioned several pain points, and I'm seeing like there are like two different strategies. Some organizations or teams actually like try to start thinking about microservices at the design time, whereas like others start to introduce them as they see pain points. Do you have any experience in terms of like when did you start seeing microservices coming around when you're just bootstrapping a new project?
Yeah, so I think starting with microservices at the beginning of a new project is probably quite a risky strategy. And that's actually what we did at Monzo. We started by, rather than building one monolith, we started by trying to break the problem apart into lots of areas and building services from that. And that meant that we avoided, hopefully, many of the problems that we'd seen at other companies around scalability, both from like the organizational perspective and also the technology. But it means that it is quite hard to do if you're attacking a new problem domain and you don't have like a really deep understanding of it. It's quite hard to draw those boundaries. In comparison, the previous place I worked, which was Halo, we went through a monolith to microservice migration. So we hit loads of the kind of scaling problems, and microservices was an approach to getting out of some of those problems.
Yeah, it seems like there are two, main concerns, like scalability and organization scalability, and like those are like the two, critical times that people start thinking about microservices.
Yeah, I think so. We certainly, when I was working on a monolith, the main problems we had were many different teams working on the same code base, and quite often not even isolated sections of the code base, but working as a cross-functional team on an area of the product, and that required you to change lots of different bits, and you kind of ended up changing the same bits as other teams, and that really ground our development to a halt in some areas.
But does microservices solve that, or does it just move that problem somewhere else? Because if you do have a component and it's, you need to add some capability to a dependency, you kind of need to do that anyway, even if it's a microservice or if it's in a monolith. Of course, if it's in a little monolith, then you can get things like type safety. We can describe our boundaries with interfaces and things in Go, for example, and it's very clean. But when we deploy it, or if we build that as a kind of big sort of microservice architecture, does it really solve these problems, or does it sort of just change them?
I mean, there's a strong argument that changing things in a monolith is actually somewhat easier. It's deployed atomically. You deploy the whole thing at once, so interdependencies between the services are not something you really have to worry about. And you've got kind of control over the whole code base. At any one point, you can kind of atomically snapshot, this is the code at this point in time, this is what I'm going to deploy. So there's an argument, especially with kind of simple, small teams and simple development processes, that monoliths will allow you to move quicker.
Yeah.
I don't want to be the one fighting the corner for monoliths. We also run microservices, but I feel like they get a bad rap sometimes.
Yeah, I definitely agree with that. If you have an interface that you want to refactor, it's much easier if you have one code base, one application, and you can change both the implementation of that interface and also all the places that use it in one go. And that's much harder to do with microservices. Unless you take very specific approaches, I think that's quite hard to do.
Mm. So you mean roll your own tooling or some other, whether it's code generation or some other mechanism that allows you to solve those kind of common problems, is that sort of thing?
Yeah, so I think there's two aspects to it. One, if you have a monolith, you generally have one Git repository or some repository of code, and all the code's in one place, so it's easy to change. And I've definitely seen lots of places where people use microservices where they have a different repository for every single service. We don't do that at Monzo. We have one gigantic monorepo.
Right.
And that means that because it's in one repository, we can have a single pull request that does that same kind of change that you would normally do in a monolith, but we can do across 1,600 microservices.
So the monorepo gives you that anyway.
Yeah.
Who had 10 minutes before we started talking about monorepos?
Yeah.
It's on the buzzword bingo, right? And I think it gives you the type safety aspect as well. So if you're just implementing services with HTTP, you're not going to get that type safety, but a monolith does give you that potentially. And you have to put extra effort in to get that with a microservice architecture.
Yeah, Kelsey Hightower was on the show, and his unpopular opinion was actually that he prefers monoliths. And he was talking about, because Tom, you mentioned it's deployed as a monolith, and he was talking about actually that is another choice you get to make. It is possible to, through, you could imagine, even if you've never done it, some simple kind of techniques, you could deploy, it is the same thing potentially getting deployed, but with different parts of it switched on or whatever. And so I suppose it ends up doing, you end up doing things like that if you don't want to incur the cost or every time of setting everything up if this thing is only going to be used in one context, things like that.
I think the distinction between microservices and monoliths is something that's kind of overblown to a certain respect. Like, you can definitely take a lot of the deployment aspects you're referring to and apply them to microservices. You know, when we do a production deploy of, I don't know, for want of a better term, a macro service, like we tend to update all the microservices to the same, like Git shar, right? So we know they all work together. But the nice thing about the microservice approach is that in between those big deploys, you know, we maybe do these big deploys once a day or once every few days. In between these big deploys, you can tune individual services. You can maybe deploy a bug fix that only touches one service, you know, in a kind of case by case basis, which is flexibility you don't really have with monoliths. But then just to like throw a spanner in the works, like you used to be able to do this with Erlang, right? Erlang arguably was a monolith, you know, a monolithic architecture, but you could easily just hotfix in a single function, right?
Mm. Could you? I don't know. Could
you could, yeah. Yeah, this is when languages were powerful and let you do things like that.
Yeah. Well, Ruby lets you call any method you like. if that's power, that's where you want to go.
Ultimate power.
Yeah. Just has a catch-all method that gets called.
Yeah, what's wrong with that?
Yeah. So you mentioned like tuning and stuff, and I think there's a lot of this as well. We think of microservices because you do have a lot more control over the deployment and the situation that they run in. And even if it's just kind of simple configuration changes, if you have an auth service that's constantly getting hit every time, you might choose to have some of those constantly running, where you might have some profile picture services that don't really get hit that often, and they can spin up and down as needed. So you get to make those sorts of different decisions as well, don't you?
I think at the end of the day, if you think about like the stream of instructions flowing through the processor, like there's, you know, the processor doesn't really know the difference between whether you're running like isolated microservices or one big monolith, right? You know, maybe there's a bit of extra RPC overhead and a few more context switches, but realistically, you know, this is all going to be one big system that we're thinking about, right? So I like to see it more as a spectrum. Like, I know that's a bit of a cop out. You know, you can even think of like functions as a service as like the ultimate, like take every single function and wrap it in its own service and deploy it, you know, in an auto scaling fashion and only run them on demand and so on. You can think of that as like one far end of the spectrum. But I think it's more about the different techniques and workflows that these enable, and even like how you can apply some of these techniques to, you know, to places that kind of seem a bit weird. So like to give you an example, one of the projects you mentioned at the beginning, Cortex, which is this like horizontally scalable version of Prometheus we've built. So we started off as a set of microservices. There's like 15, 20 microservices. And it's fine. We run on Kubernetes. You know, the marginal cost of another service is trivial. Like it doesn't matter. It's easy to add more services. But as we saw more and more people try and deploy this thing, you know, it's an open source project. You can go and download it and deploy it yourself. And it's just about to go 1.0, in fact, in a few days' time.
Oh, congrats.
Thank you. It's just a number. But yeah, as we saw more people use it, we realized actually it was a huge barrier to entry to like have to deploy 15, 20 different services to run this thing. So what we ended up doing was compiling all of the different services into a single binary and having a little way in which they kind of could run in a single process mode and wire them all together, you know, with some internal RPC. Actually, it's just, they still just use gRPC to localhost. And now you can actually like a single binary, a single process, a single command, run a Cortex node, and it's still horizontally scalable and it's easy to deploy. And of course, we still run it as a microservice internally because that gives us the control knobs and the flexibility and the ability to go in and set flags on this and roll patches out to that and so on. But I don't think like you have to start from a point of view of like, I'm going to just do microservices or I'm going to just do monoliths. I actually think like it's way more nuanced than that.
And you get the kind of best of both worlds.
Isn't this also like super useful for development time? Lots of people are like having trouble just running things like locally or in a staging environment. So maybe we can like provide several ways of deploying things for people who wants like all the flexibility. They can maybe go and like deploy microservices individually.
Exactly. Yeah.
But at least there should be like a simple, like more like a monolith way of deploying things, at least
I mean,
for people who
100%.
doesn't need that flexibility and simplicity.
Yeah, 100% agree. We call it airplane mode. It's the, you're flying transatlantic, you don't have a Wi-Fi connection, you need to run it on your laptop. Like, we call it airplane mode.
Yeah, that's a cool name.
Yeah. It's a shame it's already taken.
I like it. Yeah. Well, you like to think different, don't you?
Oh.
I think we're definitely seeing that with other projects as well. So Istio, for example, I think version 1.5 is combining the various services into a single deployable binary. And that just makes it much simpler for people who are going to operate that, but they still have the separation of those components.
Yeah, and how many builds of Kubernetes are there that deploy as a single process, right? Like, is K3S, is that one? Minikube, that was what, there's just so many where, we'll just embed etcd in and we'll, I think the other thing that occurred to me is like, name a successful, widely deployed open source project that's microservices oriented. Kubernetes doesn't count.
Yeah, I think that's fair. I think the overhead to deploying those kind of systems is just quite high.
Yeah.
So it requires quite a lot of investment into that ecosystem for you to want to go, like, get past that hump to actually benefit from it. And even if you want to then try it out locally, I mean, this is a problem that we have experienced at Monzo with local development. We have 1,600 and something services right now. 500 or 600 of them connect to Cassandra. Turns out a single Cassandra Docker container does not like 500 or 600 binaries connecting to it at the same time. So that requires you to optimize those things a bit better locally. Yeah, it's not something that's easy to run on a single local machine.
So 1,600 services. What are some examples of those services?
When you say 1,600 services, like, what are you measuring there?
So I think it's actually a lot simpler than I think people might imagine. The thing that I've noticed is there's a lot of sticker shock. Whereas if you described any complex application being made up of 1,600 classes, people would be like, oh yeah, of course, that's software, right?
Yeah.
So they vary quite a lot. But there's generally, when we say services, we mean each one of those is an independent Go HTTP server that has a number of functions, handlers that it will respond to. Many of them connect to a database. They all have their own databases when they do, but they range quite a lot in size. I think the difference is we have lots of quite a lot of high-level systems, which you could probably model as a much smaller number of monoliths, but it would still be many monoliths. And within those, we've divided them up quite granularly. So as an example, we've built our own MasterCard processor. So Monzo is both an issuer of cards, many services that make that happen, but also a processor directly connected to the MasterCard network. There will be one service somewhere that probably validates the signature of a CVV3 on like a Google or Apple Pay transaction. And that's relatively complicated. So having it as an isolated chunk of code is a useful thing. So I think there's about 100 or so MasterCard services that make up a MasterCard processor. And then you can repeat that until you get to the number that we're talking about.
Sure, yeah. Are you talking about like 100 containers, 100 pods, or like 100 deployments, 100 stateful sets?
So in Kubernetes, that would be 100 deployments. Each one of those will be independently scaled with a number of pods, at least 3. Some will have, probably not in the MasterCard flow, but some will have 100 plus pods spread across different availability zones. But yeah, so there'll be 1,600 plus deployments. I think 6,000 or 7,000 pods, something like that. And yeah, some of them only have 3 because they're really straightforward. Some will handle emoji, so they're a bit less critical. Or maybe more critical, who knows? But they vary in like size and like importance, basically.
Do you run regionally within Monzo? And would you like count the same service in 2 regions as 2 different services?
So currently we run across 3 availability zones and some physical locations for a variety of reasons. And those would still be, we treat that as like a deployment. I think as we move into having many, many Kubernetes clusters, that deployment that many of our engineers will see may translate to many Kubernetes deployments, but we would still see that as kind of one deployment of a service, just running in different geographic regions. But yeah, I think like the thing that we're trying to do is provide isolation, which we kind of talked about, and the ability to independently tune them, but also reducing that the blast radius. So as an example, we don't really have one API. If we built many services that broke up our domain logic, we would have just ended up with one huge application that was an API that provided that to our apps and various other parties. So instead, we kind of follow a similar pattern to Netflix, where we have like a gateway, a bit like Zool. And then behind that, there's 200 or so APIs. So every path is a different binary, which is a different deployment. So lots of moving parts.
Yeah, if that was a monolith, then calling a function to say validate that number, that CCV number or CVV number, whatever it is, that it's kind of obvious what you would pass into a function because it would be in the arguments, and it's kind of obvious what you get back. How do you describe those ins and outs of each service? Do you have a consistent or sort of standard way of doing that by now?
Yeah, I think you need those kind of consistent approaches. If you're going to have a lot of microservices, I think you need a lot of consistency. So we use protocol buffers, and that allows us to define an API in very concrete terms for each one of the services. Similar to gRPC allows you to define a service that has many endpoints within that definition, and each one takes a very concrete request and response type. So you get some type safety. Unfortunately, without extensions to the protocol buffers, it doesn't support the kind of the breadth of types that you would get if you had one application. But in many cases, we can support that because we control the whole code base. I think one example of that would be like a money type. If you're ever using money in an application, please don't use 64-bit integers to store pennies or cents. Yeah, it turns out some numbers can get really, really big, and some numbers you need a lot more granularity than 2 decimal places. So we have an internal money type that's very well tested, and we can pass that across the boundaries by unmarshalling and marshalling.
But what is it, like a string then? How have you done it?
We pass it on the wire as a string, and then it's passed as a decimal format, but then that's converted into a type.
A special type with, yeah.
Yeah.
What up, nerds? I got some pretty awesome news to share with you. Pluralsight is totally free for the entire month of April. I'm not kidding. Seriously, head to pluralsight.com/changelog and skill up while you stay at home. For the entire month of April, you'll get access to over 7,000 courses from experts in software development, security, cloud, and data. There's never been a better time to skill up. Head to pluralsight.com/changelog. Again, pluralsight.com/changelog.
Yeah, so we talk a lot about teamwork and microservices helping kind of larger teams. And I suppose the argument goes that essentially you can have teams that are somewhat isolated and they sort of map neatly to the services, hopefully, that they're providing. And they kind of don't need to worry too much about other parts of the system. They can get to focus in their little boundary. I've heard that said as an argument. Are there team-working advantages to microservices, or can you get the same thing with monoliths?
I think that's really the big advantage of microservices, is the isolation extends all the way down to the development process. My experience tends to be that teams look after sets of microservices and not just individual services. And that they tend to, I always normally find that set of microservices could easily have just been a micro monolith or a microlith or whatever, catchy phrase you want to use for it today. But I still think, dividing code up along team boundaries, Conway's law is super important. Like it's both a kind of necessary evil, like you have to do it, otherwise people's productivity is terrible. And it's also kind of like, it's really detrimental when you want to actually get like cross-service flows in place. When you want to do something that's going to end up touching tens or hundreds of services, you have to talk to tens or hundreds of people.
You mentioned that there's always an affiliation between the team and the services or like a service group. I'm seeing like some common services end up being in a bad spot in terms of lots of people are trying to, contribute like small fixes and so on, especially like in organizations where there's a single monorepo and it's so easy to just, push things. What do you think about that? Like, I'm seeing it like maybe it's not a super critical thing, but I'm seeing some organizations tend to just, enable that culture, which might be good or, might be bothersome.
I think ownership is definitely very, very important. I think the best way to enforce that is every service needs to have a clearly defined owner. And we use GitHub for code review, which means we can use code owners within the repository. So it means each service can have a defined owner. I think any of the engineers in the company can propose a change, but the code owner has to approve the change. I think that's really important. It gives people the flexibility to fix problems that they experience rather than the problems being hidden behind this API that they find frustrating. You can see what the problem is. You can potentially fix it. That means people are really happy because you fix bugs for them. But the flip side of that is you still have the safety and control where people who have the expertise and deep understanding of how those systems work can review and approve the changes and also make sure that it fits in with like the longer term direction of how that system is going to evolve.
I think this might be an advantage of microservices compared to monoliths, because if there's a monolith, people just like are all over the place because there's no like one person who can control the deployment or like has an authority to say no. In some cases, you can have the like same sort of like ownership in a monolith, but I think with microservices you have like more authority because the deployment is really dependent on a particular team, so they can just say no and like they don't have to accept it, the change, or they have like more like power to like not to push things.
Right, but that could be super frustrating, right? When something that's really important to you is not important to them.
Yeah.
Like when they just refuse to, that feature doesn't belong here. Or, I found in organizations that have adopted monoliths, like sometimes you can get that microservices. Sometimes you can get that kind of, a bit territorial. This is my microservices. It's done in my style. It's done with, what I think should be the right way of doing it. I think what I've always found works very well to diffuse that. And it works in open source similarly. It's like, you've always got to have the big hammer of like, I'm just going to fork your service. If you don't want to do it the way, then I'm just going to run my own.
Completely. I'm seeing lots of people are also like proxying things. That's also a really good way because you can just like slightly tweak the behavior and then like can fall back to the other service to do the real thing. So yeah, there's like all these like different cases that microservices actually enable.
Right. Yeah. I mean, as you said, like you can always do code owners in a monolith. Like the flip side of drive-by commits in microservices is, I've got to go and redeploy that. I've got to go and test it and drive it through staging and so on. So, I think we could all agree that microservices mean you've got to invest a lot more in tooling, a lot more in automation to kind of get rid of some of that toil around like the deployment and the CI and the CD and this kind of stuff.
Do you think that differs from a monolith, or do you think at a certain point you just need a lot of tooling when a development team hits a certain size?
I mean, it's a fair point, right? I think in the monolith world, it's much easier for an organization to invest in release engineering because it's like, I'm going to have a person whose job it is to push out the release every day, every week, in a microservices, okay, now I've got 100 teams that all need a little bit of release engineering, but none of them quite have enough of a problem to really justify it. But, you can make the argument in both directions for sure. Like it's not clear cut. I would like to change the subject though, because so I want to make one observation. Like one thing that hopefully we can all agree on is like figuring out what's going on in a microservice is much harder.
Really? Why? In a microservice?
In a microservice environment, my request is going to ping between, let's say, hundreds of processes on hundreds of different machines. Like figuring out why it's slow.
Right.
Matt with two T's, you're smiling because I think you know exactly where I'm going with this, right?
I'd say yes and no. I think it just depends on the tools that you have. If you have a monolith, then we have pretty good tools, right? And you can run them on your computer. You can run debuggers. We have a tool set that's evolved and is quite easy to access, right? Whereas to get that same level of tooling and insight, you have to deploy a lot of stuff potentially. And those tools exist now. And I think getting like really good metrics and understanding of like how things are performing and then using like tracing and various other systems can give you that insight, but it's harder. I think that's fair. And that, because it is harder, I think it's a trade-off of, is that the most effective use of our time? Or would it be easier if we just had a smaller number of bigger applications? And I think in my case, like my personal experience has been with tracing and relatively simple metrics. If every server has metrics on its request response times and the clients that are sending requests to those servers have request response times, instrumentation on like your databases and that kind of thing, I think I find it quite easy to pinpoint which service has a problem. And at that point, then you're into profiling and various other problems.
But there's a whole class of problems that exist independent of a single service, right? There's a whole class of problems that extend from the composition of tens or hundreds of services.
And you've put the network between all of them as well, right?
Well,
Exactly, yeah. Compared to like a function, by very fundamentally speaking, having microservices has a lot of layers to go through, and, being able to pinpoint like a single call or like single service plus a call.
Especially as soon as you layer that on top of an orchestration platform, and if you have
Kubernetes.
like an overlay network maybe that's like moving things around, if you actually want to trace where a packet's gone between your function calls, essentially, that's quite hard sometimes. I think the thing that makes that okay is you have a lot of layers of abstraction, and most of the time those abstractions are pretty good. So the majority of cases, you don't need to dive too deep into how those abstractions work. That's not to say that we've not had problems where we've had to go really deep on like particular network problems. I think we upgraded our overlay network at one point and the MTUs were subtly different. And that caused some problems that we weren't expecting. And it took a long time to find what they were. But yeah, having the right tooling, I think, is essential.
Yeah, as a cloud provider, our main job is sometimes feel like it's like really navigating all these problems and like trying to figure out like whose problem it actually is. Because, from the customer's perspective, it could be anything. It could be their problem. They sometimes don't know if that's their problem. So all those like problems are leaking to us, and we have to like the right tools and the capabilities to be able to like navigate the problem and like be able to pinpoint to certain things.
Yeah. Well, Matt, you mentioned these abstractions. Common services can be little abstractions of their own. And sometimes in monoliths or any time you have common services or common functionality, sometimes it doesn't quite serve all of its masters very well. So you end up with a kind of Frankenstein service. How do you fight against things like that happening? And do you have any particular kind of strategies for it? If there's a service that does almost what I want, do you do that thing that Jana was talking about, where you could potentially proxy and that's almost like a subclass kind of thing? But then how do you keep track of where that's happened?
I think in general, we try and avoid abstraction where we can, because most of the times we've seen a problem and thought that it was some subcase of a much larger problem. We've actually been wrong, and we've not been able to predict the future. And so when we've added those abstractions prematurely, we've just added complexity, and those things have made it harder. So the trade-off there is effectively efficiency. And what I mean by that is, I think something that I was talking to someone from Amazon, you could potentially end up with many teams that have essentially built something that's very similar. And that feels like a really bad trade-off of time, except what we often don't factor in is the trade-off of talking between all these teams and the communication overhead, and actually trying to build one universal product that solves all of those use cases. Whereas actually it might be better to just have a couple of similar kind of things, but they're very tuned to their specific case. So yeah, we have many core services that kind of provide common functionality. Those evolve over time. So we refactor them occasionally, and we change some of those models effectively. But yeah, we try not to prematurely optimize those because there's quite a high cost to it. We definitely do have some other proxy things we talked about earlier.
I'm also seeing proxying is a good way to sometimes debug things, like people just proxy to be able to, collect more data over the thing. Yeah, so that's also a legit case, which is a separate topic, but, I just wanted to interrupt the discussion.
That's the whole service mesh idea, isn't it? Yeah. Proxy everything too.
Yeah, I've definitely seen that with service messages.
Yeah.
You could do that with, we used to use Linkerd, and one of the cool things...
Famously.
Yeah, and one of the cool things with Linkerd was you could use dtab as like routing rules that could decide based on certain parameters where your request would go. And a common use of that, which isn't something that we used, was to route very specific requests, say for a particular user, into a proxy so that you could debug log the stuff between services. I mean, it adds extra hops and complexity, but from the sounds of it, people who used it, it was super useful.
That is a cool idea. And you can deploy that service live and get an insight live, can't you? So you'd struggle to do things like that with monoliths without deploying the whole thing, probably.
Yeah, I think if you're turning on like CPU profiling, do you turn it on for a particular code path or like for the whole application? Or you can just turn it on for one application because it's subdivided so much that you're only affecting a small percentage of your overall application.
Cool. Yeah, so what about like, Tom, when you think about monitoring and things like this, does anything change when you have microservices versus monoliths, or do your needs essentially stay the same?
No, I mean, loads of stuff changes. The simple, first order stuff is just the sheer volume of moving parts. You've gone from effectively having a single major process per machine to hundreds, right? And each one is going to export its own set of metrics. So the sheer volume, just from a metrics perspective. But we already talked the level of complexity you really necessarily need to debug performance issues in large microservices architectures, like tracing, right? This is necessary. You have to have this.
You say that. We got a really long way at Monzo without a good tracing system.
I mean, I didn't say you had to have a good one.
We had quite a bad tracing system that I wrote a long time ago.
Was it just you running around?
Probably about as good.
I mean, most people's tracing systems is grepping a unique identifier through a log, right? Which is actually kind of gets you most of the way there. Yeah. You don't need fancy visualization. You don't need a lot of things, but that's still tracing, in my opinion, at least. You get a long way there, but you still need that. It's the first thing people introduce, in my opinion. And it's, especially there's a big difference, I think, between latencies effectively. If your latency class is a couple of 100 milliseconds, then you can get away with a lot of kind of brute force and ignorance. But if you are doing high volume, if you're doing trading, if you're doing anything where you're expecting to handle a huge amount of small things, low latency applications and so on, tracing is just 100% necessary. And then, the sheer volume, we've talked about volume is one of the main things, but also you have this extra kind of dimensionality to your data. You tend to, we've already kind of mentioned Kubernetes, right? But no one really does microservices without some kind of orchestration system. And that orchestration system has information about the things that are running. So this is, any kind of observability system, whereas previously, I remember the billing system is on a server called John. I'll just go and look at that server. You don't necessarily know that anymore when you're in a microservices architecture with some kind of orchestrator. So you have to have a way in your observability stack, right, of incorporating a lot of this metadata and this extra dimensionality. And this is why, I think this is why we've seen the rise of systems like Prometheus, because they support this multi-dimensional data. And they support very rich integrations with things like Kubernetes. And I think that's one of the drivers behind the demise or the lack of popularity around things like Graphite.
Yeah, I think those things have been really essential for us. Both being able to just pump a lot of metrics into a system and then go and introspect it later. And both to use that for kind of investigations later, but also monitoring in real time. And then, the tracing mechanism, we use Jaeger now. And for a while we had a system which would use structured logging to propagate a request ID. So you could look at all the log lines across 100 different servers to just pick that needle out of that haystack and combine them all together. And I think those were the only real ways we could understand those kind of things. But with those tools in place, I think it's quite useful or really beneficial. One of the questions I was going to ask, actually, I think one of the things you get for free if you have that approach is we have many, many services, and a call graph crosses many of these service boundaries. And each one of these boundaries has all these automated breakpoints effectively that are instrumented. So every call between a service has the perceived time from the caller and the server. So you have all these checkpoints all the way down your call graph where you can see the performance of different things, which engineers don't need to think about. They just get for free because the client that we use adds them. How would you do that if you were building a monolith? Because you'd have to remember to add them, presumably at all these different places. And then that depends on the team, or is there a common approach?
I think I'm building something, and we're a tiny team. And I think team size definitely plays a big part in this decision-making process around this subject. So we're a tiny little team. There's just two of us building a thing. And we still have a kind of service abstraction a little bit because we have front-end client that's being through APIs is interacting with the backend. So from the way that we've done that, we've used Go interfaces actually to describe our interfaces. And then we've used the reflection tools in the standard library to look at those interfaces and then generate everything we need from that. So we do have an opportunity from that tooling to generate middleware, that matches it could be strongly typed too, because it's generated dynamically from these templates. But I think you'd end up with something like that. Otherwise, it's a case of just a bit like we do with errors in Go, where you just have to remember to do it every time. You have to do it.
I mean, there are other languages exist, right? And other languages have more elegant solutions to this.
What do you mean other languages exist? Not on this podcast, baby.
Am I allowed to use the J word here?
Yes, please. Of course. Everyone's welcome, Tom. You just won't necessarily be asked back.
Are you going to edit this bit out, are you now, man?
It gets bleeped out automatically if you say that word.
You were railing on Ruby for having an accept all method when you call it on a class, but that pattern is super useful for building this kind of middleware you're describing, right? Suddenly I don't have to run a code generator. I don't have to interface everything out. I can just add a proxy class in. It intercepts all messages and instruments them. And this is how people did it in monoliths for a very long time.
Austin Clements has an idea to automatically maybe intercept things for instrumentation purposes. So this has been this idea has been around for a long time, but nobody actually did anything yet for Go. So
what is it, Jana?
So we want to be able to just arbitrarily intercept all the function calls in order to collect some data, so we can see all the execution trees, and potentially generate some sort of visualization or run some analysis to see where are some of the hot paths and so on. So he was interested in doing some work around this, but there's a lot of other things going on, so this hasn't been a high priority for a while.
And you can always do this with profilers, right? Profilers, pause a thread, sample its stack, done. Yeah. So the techniques to do this, you could actually argue, right, that the technique of automatically instrumenting, RPC boundaries is the newer one, right?
It's a profile.
Yeah, I mean, it is.
Yeah.
Anyway, if you were wondering what I was 3D printing, it's a clamp.
What's that for?
Nice.
It's for
bright orange.
It's like a Monzo card.
It's because I'm just such a big fan of Monzo, Matt. Yeah. But it's a clamp look.
Yeah, but
Nice.
but it's a podcast, mate. So you've got to describe it. What do you mean a clamp? That's not going to make any. Imagine someone listening to this on a podcast.
How do you describe a clamp? It's a thing that you use to clamp things with.
Fine, but why?
It's got a
Why?
thing.
Yeah.
I'm Matt. You clearly don't understand 3D printing if you're asking why.
Okay, fair enough. No, that's a good point.
Hi there, this is John Calhoun, one of your Go Time panelists. When I'm not working on Go time, I create programming courses that help developers level up their Go skills. And one of my more recent courses, Algorithms with Go, is live, and I wanted to invite you to check it out. So it's completely free, and in it we explore how algorithms and data structures work, as well as how to actually implement them in Go code. So if you've ever had an interest in learning about algorithms or data structures, or if you felt like you understand them conceptually but just couldn't nail down that coding part, this course is going to be great for you. We actually dive into coding everything, we work on practice problems, and it's a lot of fun. You can sign up completely free at algorithmswithgo.com/GoTime. Again, that's algorithmswithgo.com/GoTime. And don't forget that last /GoTime bit. It helps me keep track of how you found out about the course so that GoTime gets credit for referring you. Thanks for listening.
So testing is another area that I think gets quite interesting. One of the things that appeals to me with the microservices is this idea that you could really well test it. You could test that service almost every possible input and output. You could test it that much if you were so inclined. And because it's so focused, then hopefully you create good tests as well. Are there other things to consider when it comes to testing? Does it get easier or harder, have you found?
Controversial opinion, perhaps. Is that testing always useful?
Right. That's actually a fair question.
Oh, yeah.
So it definitely is. I should probably clarify that. And testing an individual service gives you really good insight into how it works and how that chunk of domain logic works. And you can test it to infinity. And that's really good unless it's actually the boundaries between your services that the problems occur at, which from my experience is usually the case. And testing across those boundaries, that's quite hard. I don't think I've seen a silver bullet there, really.
And honestly, how is isolated service testing any different from unit testing?
It is just unit testing.
Right. So we already know how to test stuff in monoliths. It's called design your code properly in well-isolated chunks and unit test it. So the nice thing about microservices, right, is it kind of forces you to do that. You can't just call random methods in a microservice unless they're exposed. That's a nice thing, but it's just enforced boundaries. That's all.
Yeah, you could just do that. You could do that yourself too, even in a monolith, and actually should be. Similarly, then the integration tests, which are they're quite difficult to do in microservice world. They're also quite difficult to get right in a monolith too. I mean,
sure, yeah. I mean, the only argument I would make in a monolith is actually orchestrating a set of, let's call them services within a monolith, is easier than within, microservices where potentially they live in separate repos, built in separate languages. At least within a monolith, you can wire them together in process, potentially.
Yeah, I think that integration testing is where a lot of the value lives. And some of the problems that I've seen with the unit testing is if you have well-defined interfaces within your service, that's great. But as soon as you're kind of testing the API part between them, one of the kind of things, the patterns I've seen is where we might stub the API response from another service. And in order to do a test, you actually have to stub many services.
Yeah, the entire thing.
Mm-hmm. Do you think that, so I'm seeing a pattern that lots of service owners are also providing their stubs or mocks and so on. Do you follow a similar strategy? How do you deal if you want to test some service that depends on another one? And are you just, generating those payloads yourself as a developer on a different team? Or are you just taking someone else's mocks or anything that is already available?
I think in an ideal world, teams that own services would provide mocks, which other teams could use. I don't think at Monzo we have many examples of that, which means we have request response types that are defined in the protocol buffers, so we can define those, but you have to effectively stub the response yourself. And that gives you some protection because if the interface changes, it won't compile anymore, but it doesn't give you all of the protection we would really want there. And that's where you then have to fall back another level to full stack integration tests where you're testing many, many different permutations of a request all the way down the stack.
Mm-hmm. It's so complicated, especially like given the orchestrators and so on. I'm seeing a huge trend. People just want to push things to production, like, or to canary, to, that's like their primary almost testing environment sometimes. That's a bit sad, but like that also like captures the complexity of the reality, especially when you have Kubernetes and like different like, deployment problems as well as like replication problems and that sort of things. I think like in the end, you just end up having the like one final test in production by pushing a canary.
Yeah, that's the kind of thing that we're looking at now.
Yeah, I mean, I'd take a contrary view there, right? Like, to what extent is monitoring just extended integration testing? Like, to what extent, like, if, and you should be running any sufficiently complicated system, you should be injecting kind of artificial load in your system and measuring its behavior, right? So, like, why not just call your integration tests, actually, it's just a staging environment, and we're just going to pummel it with artificial load and use the same production alerts, the same, monitoring and playbook and everything we use on prod. We're just going to use it on integration.
Yeah, that's true. It's also like common to actually mirror the incoming traffic, set up a staging environment or like a testing environment and like use the same load with similar payloads. That's also very common.
That's something that we're building at the moment.
Mm-hmm.
That's a better quality test than any kind of artificial contrived
definitely.
Integration test. It does, again, come back to that point of you need better tooling, right? Because the only way that's ever going to work is like continuous deployment, is, techniques, config management, like ways in which you can ensure your staging environment is incredibly similar to production.
Yeah, and either ways to do it in production where you have guarantees it won't affect your like customer data or various KPIs that you have.
You mean test equals true?
No, there is like a lot of people will argue for testing in production, and I'm not one of them, but they've got some very good points. Like, if you can arrange a system, I've never been a huge fan of service meshes, but this is one of the things they can do, which is really kind of nice, is partition off, a separate area of effectively production that you can use for testing. And that is kind of a nice system.
Yeah, there's kind of two main areas that we're looking at the moment. So one of them, we ran our last crowdfunding through the same platform, which at face value might sound insane, but it allowed us to use many of the same systems to make things reliable, but it requires you to load test lots of things. So we built a shadow traffic system there where we can multiply traffic at our edge, and we can replay that traffic through the production infrastructure so that we can effectively get the same usage patterns, but just dramatically scaled up. And we use that as one kind of load testing system. We run that periodically. And then the other aspect, is the service mesh approach that you mentioned, Tom. So one of the things that we've added recently is if you're propagating a context all the way through your requests, which allows you to pass trace IDs and various other useful stuff, we can propagate the environment through that as well. And we have mechanisms to make sure they're not modified. But that allows us to, mirror production traffic into another environment, or mirror staging traffic into another environment. Those are the things we're kind of like looking at the moment. So not in production yet, but we've got kind of prototypes of those running in our staging environments at the moment for testing and isolation between different teams, to be honest, which is a big benefit there.
Oh, that's so cool. Well, actually, it's time for our very regular part of the show. It's time for Unpopular Opinions.
Unpopular opinion.
I actually think you should probably leave.
Unpopular opinion.
So, anybody's free to shout out. Do you happen to have an unpopular opinion? It doesn't have to be tech related. I think our first one was Julie Q saying she liked taxis in New York. So there you go. So,
What?
Yeah, yeah, she loves them. Absolutely loves them. Who
It
knew?
doesn't have to be tech related. You didn't tell me that.
Well, if you've got a tech one, then that's all right, mate. Do you have any popular opinions, Tom?
No.
Okay, well then, do you want to do an unpopular one?
I think I'll choose configuration management. So I'm going to say, like, obviously no one loves YAML. That's not an unpopular opinion. But I really despise Helm. And for good reason, right? I don't want to belittle the work that the engineers have done, and it's incredibly popular, so clearly they're onto something. But the level of like boilerplate templating and repetition that's been encouraged by Helm is something that really grinds my gears. And we at Grafana Labs, and we've been encouraging like anyone who will listen to use something called JSONet. So JSONet is this config language that like extends JSON with functions and comprehensions and all the jazz, right? And from there, it has this really nice operator that allows you to compose together two dictionaries, but merge together two dictionaries. And so my unpopular opinion is like JSONet is awesome and is the future. And I know, and this is a call out to Bartek, I saw your thread on Twitter at the weekend. I think JSONet is awesome, and we use it for all of our Kubernetes config management it used to be a project called KSonnet, and now it's Tanker. And we use it to distribute all of our alerts, our dashboards, anything like the Prometheus mixin, the etcd mixin. These are all written in JSONet, and I think this is super powerful. And so my unpopular opinion is that JSONet rocks, and that we should all use that.
Great, and we'll put the link to that in the show notes. Mr. Heath, do you have an unpopular opinion, mate?
Yeah, I think the microservices one is quite unpopular, to be honest. Judging by the reaction on the internet most of the time. I don't want to it feels a bit of a cheat to kind of continue the conversation we've had.
No, not at all.
I think the unpopular part is when people see a number that describes something that you don't have context for. It feels at face value, rather than finding out more information, usually the kind of sticker shock value is the thing that feels quite unpopular. Yeah, and I think the part of that there is really what even is complexity. I think it's really easy to look at a system that has many, many components and see it as being very, very complex. But if you don't actually get exposed to all of the complexity all of the time, you only deal with a small subsection of it. And by breaking apart systems into many smaller components, each of which is very simple, I think actually that complexity aspect can kind of go away. Also, just different teams can work on the different aspects of the complexity. So yeah, that feels quite unpopular whenever we discuss it. I think, the microservices thing works really well for some organizations, but it doesn't work for everybody. It depends on the problem, really.
That's a great one. I think that's fine. Yeah, I think about beginners with this, because as we've kind of started, we've sort of said that when you're starting out, or if it's a small project, you don't need necessarily to build the investment needed to build out the big microservices thing. And that might leave some people in a situation where they only work on small teams and don't ever get exposed to any of this kinds of ways of working. Are there any things that beginners can do to sort of get a bit of exposure to microservices, or is the answer to that you sort of have to be on a big team, because that's really when things get hard anyway?
I think a little bit. I think if you're building a product, then scaling or the need to scale is a problem you only have if the product's successful, right? You only have to scale things if people like your product and they want to use it. But yeah, the scaling part has lots of challenges. So yeah, it depends really. But we started right from the beginning with microservices, and we based that on prior experience, having worked on those kind of systems before. And it definitely slowed us down at the beginning. I wouldn't recommend diving straight in on a new project with that kind of approach. So I think there's a natural transition point where a project or product goes through that bit.
And it's probably a better way to do it, because it's more obvious, isn't it? When you are feeling the pain that your monolith is sort of not doing what you want it to do, and you're feeling that pain, you're in a much better position to design a solution that's going to work. If you try and do that in advance, some things I think are obvious and they seem obvious, but you can't really beat actually building it and living with it and seeing this thing in the wild to then get a better sense of how it behaves.
Yeah, and understanding the problem space. So, for example, we have a transaction service that represents what a money transaction looks like. And it's not the accounting concept, it's the visual kind of representation to a customer. We built the core part of that product before we released prepaid cards.
Oh, wow.
Our first prototype was P2P, like Venmo or something. And we built a transaction service as a part of that. Now we've evolved it a bit since, but clearly I made a load of assumptions 5 years ago based on very little knowledge of how that might work.
Some of them have stood the test of time by the sounds of it.
I mean, some of them, but not a lot. Yeah. So I think like you learn stuff as you go along, and being able to change stuff rapidly is probably the most important bit.
Yeah. Jana, did you actually have an unpopular opinion? I don't know if you've said one in a while.
Sure. I actually have an unpopular opinion about microservices. Even if you're working for a small company, it's a microservices environment. Even if you have a monolith, like you still have like some external dependencies, or it's just like really you're not exposed to a lot of like scale related issues. But just being in a large organization, working on a single service is not quite different than working for a monolith. Like it's you're just very focused. That's the main reason microservices exist as a way to scale the organizational problems. Most of your time is just really isolated and focused on a single service. And yes, you have some external dependencies and so on. And at a small company, you're likely to have an external service from a different provider, probably. So you can still put some of these like practices in your daily routine, like the stuff that we talked about, monitoring and debugging things. Maybe you won't be able to, touch all the specs in terms of building this internal tooling that like works very consistently, or like having like some core services, whatever. But you can still, get a good feeling of what it feels to work in a microservices, like primarily a microservices environment. I mean, everything is a microservice in the end of the day. When they get bigger, we just split them more.
That's great.
Yeah, and I think that reinforces the idea that even when building a monolith, you should think about how you may separate it out in the future. And that's just good engineering, right? Build, nice interfaces internally because they might become external interfaces, in a month or a year.
That's great. Yeah, well, this has been awesome. I've learned a lot. I'm sure that our listeners have too. That's all the time we have today. So thank you very much to our guests. I know it's sad, isn't it? You'll have to come back and join us another time, Tom. You're gonna do that?
Oh, yeah, am I going to be invited?
Yeah, I don't know.
Only if you 3D print something again.
Yeah, not a clamp.
What can I 3D print next time? Not a clamp. Oh, what's wrong with my clamp? My clamp's lovely.
Something more boring. Yeah, it is lovely. I don't want to... I mean, can we take a picture of it for Twitter?
I think lovely is the right word, right, to describe this clamp.
Yeah, let me just screenshot.
I didn't design it, by the way.
You just download that. Got it. Thanks.
Yeah, you wouldn't download a clamp, would you?
No, I probably wouldn't. Okay, well, so as I was saying, Matt Heath, thank you very much, sir.
Thank you very much.
Tom Wilkie. Matt, if people want to find your videos on the internet, what would they type in? Your name, probably, right?
Yeah, I think so.
Go on, then,
Although, I'm now terrified of what comes up.
you should have checked that, mate. You should definitely be checking that. I check that every day. Not really.
I can believe that.
No, I don't really, mate. Okay, well, that's it. I tried to do a good ending of the show, but instead this happened. See you next time.
Thank you.
Thank you for listening to this episode of Go Time. There are a couple awesome community events upcoming that we'd like to shout out. Go Remote Fest is on April 26th. That's a Sunday. Check it out at goremotefest.com. Also, the Go Git Community Conference is happening on May 19th and 20th. The CFP is open, and you can learn more at gogitcommunity.com. I'll add those two URLs to the show notes for easy click-ins. This episode was hosted by Matt Ryer and Jana Dogan, with special guests Matt Heath from Monzo and Tom Wilkie from Grafana Labs. It was produced by me, Jared Santo, and our music is by the mysterious Breakmaster Cylinder. Thanks again to our sponsors, Fastly, Linode, and Rollbar. That's all for now. We'll talk to you next time.